In this video, we want to review some characteristics of quadratic functions, mainly the shape of the graph, the equation of the axis of symmetry, and then the vertex. Let's see if we can deal with given a more challenging quadratic function. We see that the version of the quadratic function given is in standard form. Y is equal to ax squared plus bx plus c is the form, where a is negative 10, b is 3, and c is negative 4. That much we know. When we're asked to describe the shape of the graph, we know we're dealing with a quadratic function because our leading exponent is 2. And we also know that the leading coefficient is a negative, and that tells us that the shape of the graph is opening down, which means there's a maximum point, maximum value right here. In other words, we have a vertex where we have an x value and a y value. We say that's the vertex. We have an idea about how wide the parabola is. The parabola is more narrow than the parent function y is equal to x squared. For the g of x function, the y values would be getting more negative quite quickly. So again, the shape of the graph, it's a parabola, which has a maximum value, opening down or concave down is another way to explain it. And the graph is more narrow than the parent function, y is equal to x squared. All right, number 2, provide the equation for the axis of symmetry. If you have access to a formula sheet and the formula sheet gives you the x value for the vertex, negative b over 2a, we can quickly find the axis of symmetry, because if we know the x value of the vertex, we know the axis of symmetry. We already determined that the a value is negative 10, the b value was 3, and the c value is negative 4. So we can use a and the b in the formula to find the x value. Remember to put the negative 3 over 2 times negative 10, which gives us negative 3 over negative 20, which is 3 over 20. The vertex is 3 over 20, comma something. We don't know the y value, but of course we could get the y value by using the x value in the equation and finding the output, or finding the y value. Number 2 is only asking us for the equation of the axis of symmetry. That means we can use the x value and create an equation. There it is. 3 divided by 20, 0.15. We know that the quadratic is going to be quite narrow. So it would look a little bit like this. And we know that the axis of symmetry right here that cuts the graph into two symmetrical parts would be x is equal to 3 over 20. And if you want the decimal version for your comfort, it's x is equal to 0.15. We don't know if the vertex is in quadrant 1 or quadrant 4. Yet, but we do know that it's to the right of the y-axis because it's a plus 0.15. Last question, number 3, determine the vertex of the quadratic equation. In 2, we already found out that the x value was 3 over 20 in the vertex, 3 over 20. Now we're looking for the y value. All we need to do then is substitute the 3 over 20 in the equation. So we'll do that. Let's do that right here. G of 3 over 20 is negative 10, bracket 3 over 20, squared plus 3 times 3 over 20 minus 4. We have negative 10, bracket 9 over 400 plus 9 over 20 minus 4. And that gives us a common factor of 10. 9 over 40 plus 9 over 20 minus, and I know I'm going to need a common denominator of 40, so I'll just do it right now. We have an over 1, so what we do to the denominator, we need to do to the numerator. So we have a 160. Just do a quick thinking check in your head. 160 divided by 40 definitely makes the 4, and don't forget the negative. And I'll just quickly create a common denominator. I know I have the 9 right there, and then the 20. I'm going to times that by 2 times the 9 by 2. So I have a plus 18. Subtract 160. Oopsie, and don't forget the negative there with our first term. Let's use our calculator. Negative 9 plus 18 minus 160 equals negative 151. Negative 151 over 40 is the output, or the y value. Negative 151 over 40 is the y value for the vertex. And we're done. Let's give decimal versions for the vertex so we can visualize where exactly it is. Negative 151 divided by 40. Negative 3.8. Negative 3.8. And the x value, 0.15, I believe. The parabola is more narrow than the y equals x squared parent. We have a vertex here of, I'm just going to use the decimal version so that we can visualize what it looks like. The axis of symmetry here, remember, was x is equal to 3 over 20. And we can hopefully see that we're in quadrant 4. Why is that? Because we know we're a little bit to the right of the y-axis. There's the y-axis. And then we're down below the x-axis. So that's a visual there. But let's have a look in Desmos. Okay, here's Desmos. And wouldn't you know, we're in quadrant 4 for sure. And the vertex agrees what we came up with. Great. What if you were asked to find the vertex, but you didn't know the x is equal to negative b over 2a? We can use our method of completing the square. Little challenging to learn, but it's a nice method. First, we'll rewrite the equation by adding 4 to both sides and changing the g to be just the y. So y plus 4 is equal to negative 10x squared plus 3x. Keep the y plus 4 and divide out a common factor of negative 10. Because we want the x squared to be a positive with a coefficient of 1. 3 over 10x. Careful with your negatives, just double check. Negative 10x squared and a positive 3x, so we're right. The strategy is to build a perfect square trinomial, because that can be converted to a perfect square or a binomial squared. And that would reveal the vertex, because our vertex form is a bracket x minus p squared plus q, or we could use the h and the k as well, some resources. But if we can get this, we've got the x value, because the vertex is the p comma q, or the h comma k. Let's do that. So we have that negative 4 here was extra on the side, so we just move it over. And now the procedure here is, we know we have an x squared. We don't know what we need to add to the trinomial. We don't know that, but we do know that we have to share the negative 3 over 10x in these two spots. And so how we come up with that is we say, oh, we're going to go negative 3 over 10 and take half of that. How you divide that in half is you times by 1/2. So that's negative 3 over 20. Here we'll have negative 3 over 20x. And here we'll have negative 3 over 20x. We will end up with x minus 3 over 20 and x minus 3 over 20. So that's our binomial squared. And then what's this amount that we need to add to make the trinomial? It's going to be a 9 over 400. That's what we need. So if we add 9 over 400 in the brackets, we're actually adding a negative 90 over 400 to the right side. So what we do to the right side, we need to do to the left. Add negative 90 over 400 to the left side. Okay, I'm going to erase all the visuals and continue with just the algebra then. Get rid of this. Okay, so definitely it's like a 9 over 40 there. So y plus, we'll have a common denominator of 40. We have a 160 on the top. 4 is the same as 160 divided by 40 for sure, minus the 9 over 40. That's going to be negative 10 bracket x minus 3 over 20 squared. Can you see how we're almost there? We have a y plus 151 over 40 is equal to negative 10 bracket x minus 3 over 20 squared. And now, running out of room, let's move right over here. We'll subtract 151 over 40, both sides, and we'll have y by itself, negative 10 bracket x minus 3 over 20 squared minus 151 over 40. Wow, got it. There it is. The p-value is the 3 over 20. Remember, change the sign right there. And the q value is negative 151 over 40. Right there. Keep that sign. So we did it. Definitely a little bit harder initially, but if you don't have the vertex form and you've got to come up with the vertex, completing the square is a reasonable method. Excellent job.